Good evening, everyone. This is my course project in Data Communications for WAN Concepts. WAN or Wide Area Networks are used to connect remote LANs. A WAN may cover a city, country, or global region. WAN is owned by a service provider and a business pays a fee to use the provider's WAN network services. Different technologies are used for WANs than for LANs. Are WANs necessary? Without WANs, LANs would be a series of isolated networks. LANs provide both speed and cost efficiency for transmitting data over relatively small geographic areas. However, as organizations expands, businesses require communication among geographically separated sites. Different technologies have evolved to support this communication requirement. Increasingly, the internet is being used as an inexpensive alternative to enterprise ones. New technologies are available to businesses to provide security and privacy for their internet communications and transactions. Once used by themselves or in concert with the internet, allow organizations and individuals to meet their wide area communication needs. WAN topologies. Interconnecting multiple sites across WANs can involve a variety of service provider technologies or WAN topologies. These are common WAN topologies. These are types of common WAN topologies: point to point, hub and spoke, full mesh, dual home. WAN operations. One is in the OSI model. WAN operations focus primarily on the physical layer or OS1 layer 1 and the data link layer OSI layer 2. WAN access standards typically describe both physical layer delivery methods and data link layer requirements. The data link layer requirements include physical addressing, flow control, and encapsulation. These are this is the common WAN terminology. One primary difference between a WAN and a LAN is that a company or organization must describe to an outside LAN service provider to use WAN carrier network services. A WAN uses data links provided by carrier services to access the internet and connect different locations of an organization to each other. These data links are also connect to other locations of other organizations to external services and to remote users and for businesses also. WAN services. WAN link connection options. These are several WAN access connections options that ISPs can use to connect the local loop to enterprise edge. These WAN access options differ in technology, speed, and cost. Private WAN infrastructure. Services providers may offer dedicated point-to-point leased lines. Circuit switch links such as PSTN or ISDN and packet switch links such as Ethernet 1, ETM, and frame rely. Public one infrastructure services providers may offer broadband internet access using digital subscriber line or DSL, cable, and satellite access. Network evolution. What is the IoT? Using existing and n- Using existing and new technologies, we are connecting the physical world to the internet. It is by connecting and unconnected that we transition from internet to the Internet of Things or IoT. The IoT refers to the network of these physical objects accessible through the internet. IoT pillars. The network connectivity pillar. There are many different types of networks: home networks, public Wi Fi networks, small businesses networks, enterprises networks, service provider networks, and data center networks, cloud networks, and IoT networks. The fog computing pillar. Models describe how data flows within a network. Networking models include the security pillar. All networks need to be secured. However, the IoT introduces new attack vectors not typically encountered with normal enterprise networks. Data analytics pillar. The IoT can connect billions of devices capable of creating exabytes of data every day. To provide value, this data must rapidly process and transform into actionable intelligence. Cloud computing. Cloud computing involves large numbers of computers connected through a network that can be physically located anywhere. Providers rely heavily on virtualization to deliver that cloud computing services. Cloud computing can reduce operational costs by using resources more efficiently. Cloud computing supports a variety of data management issues. It enables it enables access to organizational data anywhere and at any time. Streamlines the organization's IT operations by subscribing only to needed services, and eliminates or reduces the need for on site IT equipment, maintenance, and management. It reduces costs for equipment, energy, and physical plant requirements and personal training needed needs. It enables um, rapid responses to increasing data volume requirements. Cloud services are available in a variety of options, tailored to meet customer requirements. The three cloud computing services defined by the National Institute of Standards and Technology. Software as a Service or SaaS. The cloud provider is responsible for access to services such as email, location, and Office 365 that are delivered over the internet. Platform as a Service PaaS. The cloud provider is responsible for access to the development tools and services used to deliver the applications. Infrastructure as a Services IaaS. The cloud provider is responsible for access to the network network equipment, virtualized network services, and supporting network infrastructure. This is the cloud models. Public clouds. Cloud-based application and services offered in a public cloud are made available to the general population. Private clouds. Cloud-based applications and services offered in a private cloud and intended for a specific organization or entity, such as government. Hybrid clouds. A hybrid cloud is made up of two or more clouds. For example, part private or part public, like that, where each part remains a distinctive object but both are connected using a single architecture. Community clouds. A community cloud is created for exclusive use by a specific community. Cloud computing versus data center. The terms data center and cloud computing are often incorrectly used. These are the correct definition of data center and cloud computing. Data center is it is typically a data storage and processing facility run by an house IT department or leased office. Cloud computing, an off-premise service that offers on-demand access to a shared pool of configurable computing resources. These resources can be rapidly provisioned and released with minimal management effort. The terms cloud computing and virtualization are often used interchangeably, however, they mean different things. The virtualization is the foundation of cloud computing. Without it, cloud computing as it is most widely implemented will not be possible. The cloud computing separates the application from the hardware. Virtualization separates the OS from the hardware. Server virtualization. Server virtualization takes advantage of idle resources and consolidates the number of required servers. This also allows for multiple operating systems to exist on a single hardware platform. For example, in the figure, the previous 8 dedicated servers have been consolidated into servers using hypervisors to support multiple virtual instances of the operating systems. Network virtualization. Um, Server virtualization hides server resources from the users. This practice can create problems if the data center is using traditional network architectures. For examples, virtual LANs or VLANs used by VMs must be assigned to the same switch port as the physical server running the hypervisor. These are the advantages of virtualization. One major advantage of virtualization is over reduced cost. Less equipment is required, less energy is consumed, and less space is required. Network Evolution Part 2. Control plane and data plane. Control plane, it is typically regarded as the brains of brains of a device. It is used to make forwarding decisions. The control plane contains layer 2 and layer 3 route forwarding mechanisms such as routing protocol, neighbor neighbor tables and topology tables, IPv4 and IPv6 routing tables, STP, and ARP tables. Um, Data plane, it is also called the forwarding plane. This plane is typically the switch fabric connecting the various network ports on a device. The data plane of each device is used to forward traffic flows. Routers and switches use the information from the control plane to forward incoming traffic out the appropriate egress interface. These are the Cisco Express forwarding. This is the ingress interface, control plane, and then CPU, data plane, egress interface, FIB, and adjacency table. Cisco Express Forwarding, or CEF, what you call, is an advanced layer 3 IP switching technology that enables forwarding of packets to occur at the data plane without consulting the control plane. Two major network architectures that support network virtualization. Network defined net Software defined networking, or SDN, is a network architecture that has been developed to virtualize the network. For example, SDN can virtualize the control plane, also known as control-based SDN. SDN moves the control plane from each network device to a central intelligence and policy making entity called SDN controller. Cisco Application Centric Infrastructure, or ACI. ACI is a data center network architecture that was developed by NCME and, and acquired by Cisco in 2013. Cisco ACI is a purpose-built hardware solution for integrating cloud computing and data center management. This is the software-defined networking. This is the traditional architecture. This is device 1, data plane and control plane. Device 2, data plane and control plane. And this is the SDN architecture. These are the devices, device 1, 2, and 3, and these are the control plane SDN controller. The SDN controller is a logical entity that enables network administrators to manage and dictate how the data plane of virtual switches and routers should handle network traffic. The SDN framework is illustrated below. Notes the use of application programming interfaces within the SDN framework. This is the software-defined networking. Application layer. This is the application layer, control plane, and data plane. SDN control and its operations. The SDN controller defines the data flows that occur in the SDN data plane. Each flow traveling through the network must first get permission from the SDN controller, which verifies that the communication is permissible according to the network policy. These are the SDN types. Device-based SDN. In this type of SDN, the devices are programmable by applications running on the device itself or on a server in the network, as shown in the figure. Control-based SDN. This type of SDN uses a centralized controller that has knowledge of all devices in the network, as shown in the figure. Policy-based SDN. This SDN is similar to controller-based SDN where a centralized controller has a view of all devices in the network. And this is the figure. Cisco Application Centric Infrastructure. These, uh, these are the three cores of components of the ICI architecture. Application Network Profile, um, or ANP. It is a collection of endpoint groups, or EPG, their connections and the policies that define those connections. And the other one is Application Policy Infrastructure Controller. The APIC is considered to be the brains of the ICI architecture. IPIC is centralized software controller that manages and operates a scalable ACI clustered fabric. The other one is Cisco Nexus 9000 series switches. These switches provide an application-aware switching fabric and work with an APIC to manage the virtual and physical network infrastructure. This is the spine leaf this is the spine leaf topology. This is the spine Cisco Nexus, and this is the Cisco Nexus 9500 switches, and then 9300 switches Cisco Nexus, and this is the leaf. The Cisco ACI fabric is composed of the APIC and the Cisco Nexus 9000 series switches using two-tier spine leaf technology. This, as shown in the figure above, this one, the leaf switches always attach to the spines, but they never attach to each other. Similarly, the spine switches only attach to the leaf, and core switches in this two-tier topology, everything is one hop from everything else. Network troubleshooting. If a network or a portion of a network goes down, it can be severe negative impact on a business. Network administrators must use a systematic approach to troubleshooting when network problems occur to bring the network back to full production as quickly as possible. The ability for a network administrator to be able to resolve network problems quickly and efficiently is one of the most sought after skills in IT. Enterprises need individuals with strong network troubleshooting skills, and the only way to gain these skills is through hands-on experience and by using systematic troubleshooting approaches. Documenting the network. Configuration files, including network configuration files and system configuration files, physical and logical topology diagrams. A baseline performance levels network documentation allows network administrators to efficiently diagnose and correct network problems based on the network design and the expected performance of the network under normal operating conditions. These are network configuration files. This is router documentation and this is switch documentation. Network configuration files contains accurate, up-to-date records of the hardware and software used in a network. Within the network configuration files, a table should exist for each network device used on the network, containing all relevant information about that device. For example, the first figure displays a sample network configuration table for two routers, while the second figure displays a similar table for a LAN switch. And system configuration files. And system configuration files focuses on the hardware and software used in end system devices, such as servers, network management, and consoles and user workstations. This is the end system documentation. Network topology diagrams keep track of the location, function, and status of devices on the network. The two types of network topology are physical topology and logical topology. The physical network topology shows the physical layout of the devices connected to the network. It is necessary to know how devices are physically connected to troubleshoot physical layer problems. While logical network topology illustrates how devices are logically connected to the network, meaning how devices actually transfer data across the network when communicating with other devices. Symbols are used to represent network elements such as router servers, host VPN, concentrators, and security devices. This this is establishing a network baseline. General procedures. Troubleshooting takes a large portion of network administrators and support personnel's time. Using efficient troubleshooting techniques shortens overall troubleshooting time when working in a production environment. These are the 5 steps to gathering information. Step 1, gather information. Step 2, determine ownership. Step 3, narrow the scope. Step 4, gather symptoms from suspected devices. Step 5, document symptoms. Questioning end users. In many cases, the problem is reported by an end user. The information may often be vague or misleading, such as the network is down or I cannot access my email. In these cases, the problem must be better defined. This may require asking questions of the end users, such as customers. Use effective questioning techniques when asking the end users about a network problem they may have experienced. This will help you to get the information required to document the systems of a problem. These are the guidelines when questioning users. Ask questions that are pertinent to the problem and end user an example of end users questions. What does not work? Like that. Isolating the issue using layered models. After all symptoms are gathered, if no solution is identified, the network administrator compares the characteristics of the problem to the logical layers of the network to isolate and solve the issue or problem. OSI reference model. It is provide is it is to provides a common language for network administrators and is commonly used in troubleshooting networks. Problems are typically described in a term of a given OSI model layer. The OSI reference model describes how information from a software application in one computer moves through a network medium to a software application in another computer. Isolating the issue using layered models. TCP or IP model. It is similar to the OSI networking model that TCP or IP networking model also divides networking architecture into modular layers. These are the troubleshooting methods. Bottom-up troubleshooting methods. So this figure, you can start here at the bottom because this is a troubleshooting bottom-up method. You can start here at physical. Next is data link, network, transport, and application. So bottom-up troubleshooting method, it is you start with the physical components of the network and move up through the layers of the OSI model until the cause of the problem is identified as shown in this figure. So the top-down troubleshooting method is you're gonna start here at the top and then you're going down and then you're gonna down. Um, that's why top-down troubleshooting method. So top-down troubleshooting starts with the end-user applications and moves down through the layers of the OSI model until the cause of the problem has been identified. You can start here at application, next transport, next network, data link, and the last one is physical. Um, Next is divide and conquer troubleshooting method. Divide and conquer troubleshooting, you start by collecting user experiences of the problem, document the symptoms, and then using that information make an informed guess as to which OSI layer to start your investigation. When a layer is verified to be functioning properly, it can be assumed that the layers below it are functioning. The administrator can work up the OSI layers. If an OSI layer is not functioning properly, the administrator can work down the OSI layer model. Next one is Network Management System Tools or NMS. These tools include device level monitoring, configuration, and fault management tools. The figure the figure shows an example to display from the WhatsApp Gold NMS software. This tool can be used to investigate and correct network problems. Network monitoring software graphically displays a physical view of network devices. It is allowing network managers to manage to monitor remote devices continuously and automatically. Next one is knowledge bases. Online network device vendor. Knowledge bases have become indispensable sources of information. When vendor-based knowledge bases are combined with internet search engines like Google, a network administrator has access to a vast pool of experience-based information. Next one is baselining tools. Many tools for automating the network documentation and baselining process are available. The figure shows a screen capture of the SolarWinds Network Performance Monitor 12 baseline view. Network Analysis Module. The Cisco is a device or software as shown as the first figure, this one. It provides us it provides an embedded browser-based interface that generates reports on the traffic that consumes critical network resources. It is displays a graphical representation of traffic from local and remote remote switches and routers such as seen in the second figure. This one. NAM can capture and decode packets and track responses times to pinpoint an application problem to a particular network or server. These are the symptoms and causes of network troubleshooting. First one is physical layer. It transmits bits from one computer to another and regulates the transmission of a stream of bits over the physical medium. Data link layer troubleshooting problems can be a challenging process. The configuration and operation of this protocol are critical to create a functional, well-tuned network. Data link layer problems cause specific symptoms that, when recognized, will help identify the problem quickly. So the next one is network layer. So the problems include any problem that involves a layer 3 protocol. Both routed protocols like IPv4 or IPv6 and routing protocols such as EIGRP, E- EIGRP, OSPF, etc. Network problems can arise from transport layer problems on the router, particularly at the edge of the network where traffic is examined and modified. Two of the most commonly implemented transport layer technologies are access control lists or ACLs and network address translation. So most of the application layer protocols provide users services. Application layer protocols are typically used for network management, file transfer, distributed file services, terminal emulation, and email. New user services are often added, such as VPNs or VoIP. Troubleshooting IP connectivity. Components of troubleshooting end-to-end connectivity. Diagnosing and solving problems is an essential skill for a network administrators. There is no single recipe for troubleshooting, and a particular problem can be diagnosed in many different ways. However, by employing a structured approach to the troubleshooting process, an administrator can reduce the time it takes time to diagnose and solve a problem. Next one is end-to-end connectivity problem initiates troubleshooting. Usually, the initiates troubleshooting effort is the discovery that there is a problem with end-to-end connectivity. Two of the most common utilities used to verify a problem with end-to-end connectivity are ping and traceroute. VLAN, VLAN, asa- VLAN assignment. Another issue to consider when troubleshooting end-to-end connectivity is VLAN assignment. In the switch network, each port in a switch belongs to VLAN. Each VLAN is considered a separate logical network, and packets destined for stations that do not belong to the VLAN must be forwarded through a device that supports routing. And that's all. That's my course project and data communications for